Thank you, and enjoy the evening.
Thank you. And now, finally, it's time for Ben from Gravity 9, who's the Director of Data Architecture, talking about data engineering for business. So give him a very warm welcome. He's been waiting a long time.
Thank you, Noel. So the topic here is like data engineering in big business, and when I sort of had that topic, my mind was a blank. I had no thoughts in my head at all. So I thought I would lean on the industry as a whole, crowdsource the content for the presentation. So I went out and asked a few people that I know, some people who hire data engineers in bulk or who operate large program teams in large corporations, and got sound bites from them. So this is all pinned off of their sound bites, quotes I've had from people who are in charge of, resourcing and sort of career development of data engineers in large corps. My own background is kind of specific. It's pretty much focused on banking, plus a short spell in the sugar industry. So I've worked for many of the large banks. I sort of started my work on the trading floor at Goldman Sachs back in the 90s. It was relaxing, peaceful, with a great work-life balance. You think I'm being sarcastic, but it just depends on what you want and sort of where you're at, really. I mean, if you don't need that many hours sleep and stuff, it's fine. It just depends. I'll tell you what, big organisations, one thing about them is you can hide in them. Not Goldman's, but some of them you can hide. So when it comes to work-life balance, if you want to do nothing at all, the bigger the corporation, the higher your chance of doing that. It's not a recommendation or a career strategy. I'm just noting that there are some unexpected dynamics. So anyway, I've been involved in. Watch out for that. That's a CV warning sign, isn't it? Involved in. Worked with, but I'm doing it anyway. Been involved in lots of large data programs at large corporations. Also been involved in hiring and running sort of medium-sized or large data engineering, data architecture teams. I've built a data architecture practice, that kind of thing. And I'm not actually a data engineer, so I know nothing about it, which I think positions me beautifully to not get bogged down in the details and talk about the hassles of large corporations, which I do know something about, as do many of you in this room, I realise. Now, it's a quirk of my personality that I interpret silence and blank stares and falling asleep as enthusiastic approval. So if you have something else you want, some other message you want for me, then just make it clear, right? Because if people are sit there going, but I'm like, sort of, they're loving it, they're really loving this stuff, and sometimes I'm wrong. So anyway, I'm going to not talk about data engineering, but what I am going to say is it's actually all on this one slide. I have like 31 others, but I can just look at this one because large corporations have, years ago I saw a presentation that was aimed at trainee data engineers in a large corp, and the slide, for better or for worse, just said, if you are here at all, you're doing one of three things: chasing revenue, reducing cost, reducing risk. That was the whole slide, and also the entire presentation. And I've thought about that over the years. It's true, it's kind of the opposite of that human-centric angle on things. It's just a fact about the fact that corporations have shareholders that want to see a certain share price in a certain time frame. And as a result, corporations have goals which are not necessarily data engineering related. And as a result, the more you want to move around and get ahead in them, the more things other than data engineering need to be added to your portfolio, I guess. I thought I'd define my terms because presentations are also data and they should have semantic metadata annotating them. Then I thought, whatever. So I just looked up two. I'm not going to read these things out, but look at how they're different. They really reflect difference in perspective. I actually picked two that were both from big vendors and both from the same year. It's just difference in attitude. You got one up there from a corporation that's process-driven, procedures. You are executing a process as an engineer. You got one which is kind of ownership-focused. You are creating and selling a product as an engineer. Two different ways of looking at things. I guess my point, though, is not that one's right. It's any corporation more than about 50,000 employees. There's going to be at least 5 or 6 views on what a data engineer is, sort of 10 or 12 data engineer job specs. And ultimately, if you want to move around, find the right place, do the best thing for your employers and yourself, you'll need to get to grips with them. You'll need to deal with people whose beliefs and vocabulary are not your own. The little cross thing on the right, I added that on the train on the way here. That's how come the fonts don't work, I expect. Or else it may be sunspots, that's also a possibility. But it's kind of trying to show, people define data engineer, somewhere there's a techie end of the spectrum and a domain knowledge end of the spectrum. People who lack both those things probably aren't doing a very good job. And there's a process execution end, my job is to take the data from membership and provide it to the churn report. And then there's a product one. I'm producing a membership product which I'm going to sell with an organisation. It's not a value judgment. It's just a matter of people can see it very differently based on what the organisation does and how old the organisation is. I'm going to look at these like 4 things. I'm going to look at these 4 things about big corporations, and then I'm going to say, what does that imply about what they want from a data engineer? And who they want to hire, who will get ahead, kind of thing. It's all one person's opinion. If I was that good at getting ahead in data, I wouldn't be here. I'd be on a yacht, probably in the Baltic. I think that would be nice. But I'll look at these 4 things, and their implications all the same. So, complex environment, lack of trust. I don't mean that in a bad way. I just mean that when you've got more than 100,000 employees, you can't really work with everybody. The assumption that everybody involved understands and agrees with everybody else. There has to be some contracts, formal agreements between people. Oversight, the larger the entity, the more regulation and compliance it has. That's also my area, so I like it, and I'm going to give it way more space than it deserves. And the technology challenges as well, which have become much more diverse than they used to be. I'm going to really rip through this, by the way. These slides don't have many words. I'm going to challenge myself to say even fewer words than are on these slides. But here's my first quote, though. By default, data engineers are in a small part of the data value chain. Good engineer comes to understand the whole chain. This guy is a guy that I know who's delivered a large financial technology product for one of the big 4. Now we have to guess which of the big 4. And he's a very, very smart guy, 1,000 times smarter than me. And that was his thing that he called out about it. And I think that he's very correct. The implication, of course, of that is to be a good data engineer, you need to be doing things other than your little part of the chain. He got where he is today by looking at what improved the client's bottom line, because he's in one of the big consultancies, and that's what he expects people to do. The trouble is that the data engineer's view is really small compared to the corporation as a whole. So this was my attempt off the cuff at the kind of the immediate environment of a data engineer. If I imagine a data engineering team, I actually left out myself and everybody I work with from this. There's probably a dotted line here to sort of people whose function is more like mine, but like sort of oversight. You don't have to deal with these things every day, every single one of them, but it's all the stuff which is around you. I guess the point is just there's kind of a lot of it. And the implication of that is that we've run many varying perspectives. There's a few like classic perspective differences in organisations. There's people who are in BAU roles and people who are in change roles, for example. That's two budget lines, 2 chains of command, yet the same actual people doing the work on the desk. It's a classic example of where you've got to think about where you're going. All these things on the right are people who have worked with me, have said them at some point or another. Revenue maximisation versus risk, data originated versus analytics, it's kind of a new one. Originally, those who owned the operational transactional systems kind of ruled, and if you wanted to get a report out of it, maybe they'd let you have some data for a report, but not usually. These days, analytics and AI are king. Yes, I went that long without saying AI, but now I've said it. I'm going to say it again and again, guys, again and again. And that's now a really important distinction, because a lot of organizations have hired a chief data scientist. 5 years ago, very few people had a chief data scientist. Now, every major corporation has one. Probably somebody in charge of regulating, managing the data pipeline quality behind those models, somebody in charge of AI ethics and stuff. All those people have got to show some return on investment. They're all being paid a lot. They've got to show some value from it. That means they need things from the data engineers, and that's a big change in the dynamic in some organizations. Business unit versus group. There's a gentleman here who works for HSBC. I wasn't necessarily thinking specifically of HSBC there. There's an example of a federated enterprise where the needs of the business unit, such as UK retail banking, and the needs of HSBC, the group, may be different. That they're not usually different, but it's perspectives that could possibly exist and could, in theory, create tensions which they eventually need to resolve. And of course, business versus IT, profit versus cost. Business is chasing revenue and thus profit. IT is reducing cost and thus increasing profit. And of course, those are 2 very different ways to look at what is actually the same sort of shareholder value exercise. And it tends to result in lots of hatred. I don't really know why this particular axis of like difference causes so much hatred, but it really does. And in most large organizations, there'll be many people whose name is data engineer, but who are maybe working closely with the business, sitting on the desk with the business users, and they think what that business user wants to do is everything that there is. And a bunch of guys sitting in the back office going, but the data pipeline for quarterly reporting is not all it could be. And they too are data engineers who believe that what they do is the data engineering need. And they're both right. I'm just saying that there are perspective differences, and the answer involves communication and compromise, which is some soft skills that everybody should have and does have, which is great. Data is a product. This was a quote somebody gave me. I approached somebody who's, strange job title, but in charge of data essentially at a big securities firm. And he just came right out with it and said data is a product, which is, of course, is the modern way of looking at it. And then he said it needs a business case, a strategy, and a salesperson. which was an interestingly kind of bottom line focused way to look at it, but then they are, a giant securities firm. That's not surprising. I found that interesting. So he went straight for the, you are a product owner as a data person, and I don't disagree with that. I bet that same firm, if I'd gone into their IT infrastructure and I'd asked people who were in charge of like bringing in foreign exchange rates sort of on some basis, that they would have said, my job is to bring in foreign exchange rates within X nanoseconds and so forth. Very different point of view in the same thing. So that's why we have structure. People have such different views of what a big company's doing that we need structure. I've drawn this big stack of bits of paper, but of course that's not realistic. In real life, the paper is just stacked far, far higher. And I've just sketched out a few of the sort of key artifacts here. I guess the point is just that it's a fact of life. If you're trying to deliver change across a very large organisation, and as a data engineer, you should probably seek to deliver change, even if the change is optimization of some existing outcome, it's still change. Then there's a lot of stuff that happens around that, and that stuff happens for a reason. It's irritating, but it's for a reason. My personal opinion is that probably one of the biggest differences I've seen between people who add a lot of value and sort of create a profile in larger organizations in this role, and those who maybe stay in their kind of compartment, is that understanding why this kind of furniture exists and simply working with it and using it for a purpose to create an outcome rather than seeing it as an overhead. I think that's a pretty big differentiator. So my message there is kind of unattractive. It's like, wallow in the paperwork, I guess. But that's just how in many ways it is. Of course, that was before a few years ago. Everything's changed recently. If you'd asked anybody 5 years ago, data in your organization is not effective, how can we give, how can we give the CIO some nice ROI on data management, data engineering, data governance for the year and so on? People would have talked about tightening up service levels and so forth. Now they will talk about two things, data mesh and data products. They're right though, because those are both amazingly good concepts. Data mesh has become a pretty pervasive way of looking at things, and even when it's not, it kind of still is, because data mesh, the original paper, I think, from Jamet Degani at ThoughtWorks a few years ago. I'm going to assume everybody in this room has read her white papers, by the way. They are essential reading. They just are, like, literally essential, like vitamin D, for example. Without that you'll die, same with data mesh. But they were very, very good white papers, and they expressed truths which are true whether you subscribe to data mesh as a buzzword or not. So one thing that I definitely see in large organizations, above a certain size, above the size, we can just have one hierarchy of data people. Once you start having multiple separate concerns, multiple hierarchies under multiple sort of important leaders or business units, is data mesh concepts. I'm not going to rehash what those concepts are, because I'm assuming everybody knows, and also because I want to encourage those who don't to read the actual white paper rather than my garbled recollection of it. Productization, the same. And again, even if you don't believe in data products, everyone does believe in them now, but even if you didn't, data products is just saying, it should be usable. It should be a thing somebody wants to buy. Data costs money to deliver. It should be worth something for that money. So it should be delivered with whatever it takes. Metadata, annotation, lineage, provenance, somebody to help you use it, a form of delivery, costing information, which allows you to use it. It's extremely commonsensical. So in a way, I think it's actually a pretty amazing step forward that some of the heavyweight waterfall artifacts that we used to have been replaced with these mesh and product concepts. And that's become pretty pervasive, even in the biggest, slowest moving ones. I really like oversight. I do love regulation because it fascinates you, because that's where data meets law and ethics, I guess, or one of the places where it does. And I just find that very interesting. This is a famous quote from somebody at Forrester. You'd think I'd know the name of the person, so I've failed with my, provide provenance here, and I can only sort of throw myself on your mercy, really. But it's really important. There is no such thing as perfect data quality. In large corporations, that's especially true. And there are multiple versions of truth, and even when there aren't, there are multiple ways to aggregate the truth, which provide different perspectives and different implications and so on. But what regulators and compliance officers and the C-suite want is not perfection, but it's to understand, have transparency. If we think these numbers are worth basing our strategy on, why do we think that? I've worked in hedge funds where people have pressed a button and the screen's come up and said, your risk is $3 billion. And that's kind of all. And it's, that's not a very interesting thing to be told. If you press it again and it says, your risk is $8 billion, then that's equally unuseful, right? Data that's not accompanied by some sort of handle you can use to understand how good it is and where it came from and why we think that is of much less value. So, and again, especially true in the large organisation, I do love oversight. I'm going to enumerate all these ones. I haven't pointed much to the slides. I'm going to point to this one. Compliance, making sure that your work conforms to rules, both external and internal. Regulatory compliance is a part of that. There are many, many important compliance things in data. GDPR is the famous one because it took everybody by storm and it has massive potential penalties, but there are so many others. And that will only increase. The previous UK government, the late UK governments, were very keen on this kind of thing, and they liked to try and be at the forefront of regulating AI and model risk. But by model risk, I mean the risks that come from automated modelling of the real world in various ways. And they put out a new one actually beginning of this year, I think, which was very interesting, tried to leapfrog American regulation. It's a really active and interesting area, which I'm happy to talk about, but I'm going to move on to data governance. Of course, that's also something which you'll deal with. In a large corporation, you're going to have somebody whose job title is data governance or head of governance or something like that, and they are going to want your data to be traced, defined, usable, secure, accurate, timely, consistent, and correct. A bonus point for everybody who knows where that list of things comes from. And you're going to want to deliver to your deadline and go home, but they're going to want those things. And evidence of those things, and you know, like something they can point to if they get challenged as to why they thought the data had those things, because they can get blamed. That happens to me all the time. Now, I once, I left a 0 off something. It turned out that all relevant phone calls have been recorded, and it's kind of a big deal with large sort of data, risk and financial outputs, and that's an overhead that you'll need to bear. It's also a positive. 3 lines of defence. How many people in this room are sort of familiar with what I mean when I say 3LD from the point of view of risk and stuff? Yeah, not that many. So large corporations almost ubiquitously have this 3 lines of defense model. There's the risk owner, the risk manager, and the risk auditor. In practice it can be many things, but the risk owner, someone doing the work, owns the risk. Somebody overseeing that manages the risk, and then there should be a separate independent function that audits the risk, and that's how risk should be managed organically, as in independently from a separate risk management function. That's important. As a data engineer in a large corporation, you're going to come across that at some point because you'll have certain duties about it. Then you've got architecture. It's a kind of oversight. Architecture used to be all about making people not do stuff. This made being an architect, which I was for quite a long time, quite a frustrating job. And also everybody hates you a lot, and you feel a sense of lack of self-worth and misery, and you frequently cry. But luckily, that situation's improved quite a lot. I think people now realise that data architecture and other kinds of architecture are about facilitating, not blocking. When I say people, I mean some of the people. And architecture can be your friends, but my point is, in a large corporation, you're going to have to be friends with whoever's on the review panel for data, enterprise, and business architecture. If you want to make stuff happen, you will need to make friends with reviewers and gatekeepers of all kinds. And then standards. I've worked with corporations that have massive global standards bodies, and it's never had much impact. That's why I kind of said the impact. My subjective experience is that global standards are probably one of the less impactful of these things. But look how numerous they are, aren't they great? And every one of them has its own paper shield and its own set of people who only get paid if that thing happens to you. So a lot of it happens. So there's a solution though. I mean, it just means you need some more skills. Here's my take on it. You'll need to do some good data management stuff. So please don't deliver data without any metadata associated with it. No one's doing that, are they? I see some guilty faces, but I shall go on. Always maintain the evidence trail because your auditors, your 3 line of defense auditor, your external auditors, the actual regulators will need that. That's actually an interesting one, but I'm going to skip over that one because it's difficult and interesting. This is the thing. Look, if you joined a big company data and engineering pipeline that was delivering crucial outcomes, and you paid attention to everybody who thought it would be nice if you answered their email and explained how you know that data profiling is happening for 70% of all the metrics defined by the control framework and so on, you'd never get your job done. It's really important to distinguish between material and less material oversight burdens. And finally, explain and sell. This is something which people sometimes grasp instinctively and sometimes fail to do. I think of my first quote guy, the guy saying you only see a part of the chain. Now he managed to explain and sell a large software system in a Big Four consultancy that doesn't normally produce software products, and he had to get past other people, and he had to have a lot of faith, and he had to do all kinds of things, and it involved breaking it down into short words for some people, and really going into massive detail for other people. And if you want to make change, In a big organisation, it's going to happen. If you're in like an organisation with 30 people in, you discuss it, and if it's good, it happens. But it isn't always that simple with 30,000 people. Now the technology chunk of this. This is an interesting one, isn't it? Someone said this to me only a few weeks ago. There was a saying in old-timey software architecture, premature optimization is the root of all evil. And there was a similar saying in data, premature aggregation is the root of all evil. People not as old as me may not remember the day when that kind of thing was current. Look at the optimization one, that was true. In software, optimization was bad. It made the developer feel clever and it didn't yield anything for business about 9% of the time. But look at this now. But now what we happen is, used to be that deploying a data solution was all about CapEx. In other words, you spend a lot of money up front to spin up a system, you wait 6 months to provision a big beige box in the corner, and after that it kind of either runs or doesn't, basically. But even if it doesn't cost you anything. These days, however, it's much more about OpEx. It costs you nothing to, like, just tell Snowflake to spin up a few more warehouses, but it can kind of bite you in about a month's time when you realize that all your Cartesian joins and stuff were costing you tens of thousands of dollars a time. 64,000 was the example given. I didn't ask, but that was a very specific example. That's a big deal. And this is a brilliant example of how what is fundamentally a matter for the CFO and the budgeting process actually has a huge concrete impact on what you as a data engineer need to do. Previously, you didn't need to optimize it to make sure it ran, and you need to calculate upfront the capacity needs. Now you need to optimize, and people are really looking for that. Yeah, I kind of said this one already. This is another interesting quote though. So okay, this is an SVP working global risk in a tier 1 bank. And he said this to me in a cafe not far from here. And he was like, yeah, my work-life balance is now very, very good. And I was like, you asshole. But he'd bet and he'd won, right? He had understood that his job in moving workloads to a new strategic platform was only of kind of existential value if it was done with understanding of the financial and strategic implications of it. Anybody can move a bunch of workloads. He had managed to position himself as the guy who can move a workload with predictable future costs and a predictable kind of impact on budget lines in a number of ways. And as a result, his work-life balance was apparently very, very good. I think there's a lesson to be learned there. I should have learned that lesson a long time ago. There's also another thing to consider here, which is that, okay, he was in the position of moving workloads to a large modern system, which everyone's heard of, but which I won't name the vendor. It works really well. The thing is, though, in large organizations, it can vary a lot. And some teams are great, and some teams are very modern, but sometimes you won't see Python from 1 month to the next. And I've overseen in the last year data engineer teams who have been entirely Excel-based and entirely SQL-based, and it's just the truth. And honestly, you're probably lucky about that. Most large organizations have multiple millions of lines of either T-SQL or PLSQL, if you're lucky. If you're not lucky, they're using something else like JCL, which was an old IBM mainframe language. Actually, JCL is not too bad, because those IBM languages are nothing if not deterministic. You can actually infer a lot from them in the way that you can't from Python. So swings and roundabouts, but it's not fun, I guess is the point. There's also Excel, there's also SAS, and all the other ones which are listed here. I quite like ab initio. I'm not necessarily saying these are all bad things, but I'm just saying there's kind of a lot of it beyond the Python and Pandas world. And the bigger you get into big old, I'll tell you what, I worked for one very large old bank at one stage, and the core banking system, the one that maintains account balances, actually knows how much you have, was called the EBC. I couldn't find out the reason for this acronym though. Eventually, after about 2 years, I discovered that EBC stood for Electrical Banking Computer, because when it had been first stood up, it was the only one, so calling it that was a perfectly good way to identify it. There's obviously more than one now. And you'll see many, many other things. Even on the new generation side, there's a dazzling variety of technologies and ways to look at it. So the point is, you're going to have to work with stuff you don't always like. Applying data ops and DevOps principles would be nice, but across the actual infrastructure of any kind of large federated multinational, it's impossible at enterprise level. It may be possible at business unit level or product level. People get frustrated sometimes about the way decision making works, even when it works sensibly. It's just, again, a size thing. In a small organization, I worked at a startup for a while. It was great. If we wanted a thing, we only had to ask those 3 questions. Does it work in general? Will it work for us? And do we have any money? Yes, no, typically. But those are the only questions we had to really think about. In a large corporation, I stopped here because I just thought, why go on? But the list of things to think about is far longer than that. So, if I buy this, will somebody says, but we have something that does that. They may say that rightly, they may say it wrongly. Do you want to work with this vendor? This is a really big deal. This is a good example of the concern doesn't exist. If you're a 30-person company, you want the product that works. If you're a 300,000-person company, you want the company you work with not to be bought by a competitor ever, for obvious reasons. You want it not to be bought by a company whose ethics or business model you aren't going to work with. You want it to be capable of making joint ventures with you, probably, but also to have a track record of making them in a way that you like and that works with your financial constraints and so on. Everything you buy will need to go to a support team and probably many, many other teams who all need to like it and not blame you for buying it. Some things work, and they can be adopted in time, and they do work, but your program, the little light in the corner of your sales report, will only stay green if you can say, platform acquired in 3 months. If it takes 3 months and 1 week, the light will go red. That can make a big difference to individuals. Maybe it shouldn't. Maybe business should be less concerned about time frame metrics, but time frames do matter, so that can happen, and so on and so on. And budget cycles and amortization can have enormous effects on these things, which are far beyond what the data engineer controls, but very much part of what data engineer deals with. Last part of this presentation, what do people look for? So I collected some quotes from people in hiring positions, people who hire a lot of data engineers. First one I got, this was the head of data science at a mid-sized consultancy. Data engineers should be software engineers at heart, specialise in data. I thought about this quote several times. I found it annoying when I first heard it, and I find it annoying now, but I'm not saying it's wrong, merely that I find it annoying. It's quite a different thing. So that's somebody who's a data scientist. So of course they're looking at the analytics use cases. What they want is really great support for their analytics. What they want is for their really clever model to just have the right data coming in so they can demonstrate their own value. And that's definitely a point. The scalability thing intersects with that as well. Proper software engineering is kind of essential for scale. It's also true organizationally. So as a data engineer, remember that big context slide I had with all those little blue boxes? And you all know what the blue boxes were and can list them by heart? Well, one of the blue boxes was called change, because you're not going to deliver stuff to the CEO. You're probably going to work within some kind of change function who will take what you do as a data engineer and give it to DevOps or developer people, or it could be completely different, because the relationship between those things is not always fixed. But either way, acting like a developer, understanding DevOps can actually be really powerful for those things. Another person I asked took exactly the opposite view. Good data engineer understands contracts, vocabulary, regulations, and core processes. So this person basically means something totally different by data engineer. This person was thinking not of somebody who will support an analytics decision by providing the right data to it, but rather somebody who understands the organization, the business at transaction rather than data warehouse level. This person's looking at the transaction processing and thinking about, does the data engineer understand the life cycle of a deal for us, the life cycle of an expenditure for us, and so on. Whereas the first person was thinking, will this person get me the aggregated information that I need? Another person, so I talked to this person, look for the usual things. I just found this interesting because this person apparently have two separate hiring pathways, both called data engineer. One for the Python, Pandas, Spark folks, and one for the SQL Excel folks of roughly equal size. I thought that was an interesting thing. If I came back in 10 years, would Python, Pandas, Spark now kind of be a bigger thing than SQL Excel? I think they'll both keep on existing forever, to be honest. It just reflects two different real-world needs. And finally, this was a more human-centric thing. So I heard this from a sort of UK CTO of a large software house. Let's do what we call a grown-up. You can see why I don't attribute these quotes, can't you? So the thing is, though, this is really true. So I was involved in training data engineers at some point. The fact that I'd never done it suited me ideally for this purpose. And one thing the thing I probably told them most was, first, keep your camera on in calls. Second, wear a shirt with a collar. And third, when the call ends, go, thanks, guys. Right, don't just stand there and think, these are really important things. It feels stupid, and I feel stupid saying it, right? But it's just kind of a fact. Large organizations are complex and have many people in. There's really no reason to make a bad impression. You've got to kind of play the game, and the game is largely about people trying to get on with each other when fate may have given them very different bodies of information to work with, very different objectives, and so on. So now we have a conclusion slide. See, I ripped through that stuff, nothing to it. So I think my core takeaways, if I was going to share 4 core takeaways with you, which I'm doing at this moment, very meta. The environment's complex, so communication's key. When there is complexity, soft skills increase in importance. If there's little complexity, there's a source of data, an engineer, a data sink, there's no need for the soft skills. The more networky that diagram looks like, the more important the soft skills are. Secondly, data engineers always have to have domain knowledge or development skills. I personally can't imagine a slot for somebody who doesn't have either of those things. One might theoretically exist, but I can't picture how it would achieve success or create change, honestly. But I think one of the two is enough. I think there are people who are very good at optimizing a particular platform, people who really understand a particular business process. Both those guys have their roles as data engineers. And creating outcomes requires proactivity. That's actually really important. And honestly, data engineer isn't a job which necessarily gives you a great view of the organization. It's not a very a good defensive position. You can't see far from it. You're often receiving information from data owners, transmitting it to data consumers without much outside knowledge of how it works. So when I've been in the position of placing data engineers and preparing them for work in large corporations, one thing I will say is, 2 out of the 5 conclusions you draw, things you learn in the first week, have to be not about the immediate job you're doing, it's going to be about the wider implications and objectives of the work. For example, you can be given a boring piece of work. You can be told, we have 65 we deal with 65 commodities exchanges where we buy oil. We'd like to write down the terms and conditions of those and how much we pay them and what the margins are and what the haircuts are and what the taxes and so on. You can go off and do that, or you can decide to build an oil exchange data product that's fully equipped with discoverability, searchability, quality information and provenance, and sell that. You should do the second one. It's almost an attitude difference, but it has a big difference actually to how much impact your work has. And then finally, it's a cliche. I can remember when I was like sort of 22 and it was a C++ developer, people saying this, the soft skills are the important ones. I was like, no, they're not. C++ is the important one. The soft skills are some, other stuff. But it's just, it's just true. And it's especially true in large, complex, multi-perspective work environments. You cannot create change only with technical skills unless you are super clever, so clever that I can't even perceive that level of cleverness. So those are my 4 takeaways, and with that, I'll bring this talk to an end so I can take a full breath again. Thanks, guys.
Thank you, Ben. Any questions, any opinions?
So I've got a question, and that is, have all companies that you have had experience with always perceived data engineering teams, for example, or data teams in general, as a cost center, or did they also sometimes perceive them as a profit center? And if that varied, how did that affect what those teams could do in a company? Because I've seen some interesting things.
Yeah, that's a fair point. I think it depends on whether the team... Historically, data wasn't a separate function. There was business and technology, and data normally lived with technology. If it lived with technology, that is a cost center, whether you feel like it's a cost center or not. It just is, unless the company's a tech company. If it lived with business, it was probably more like a profit center, depending on how the company did things. Then, some years ago now, data became its own thing in some organizations. And it became seen potentially more as a profit center. There was a generation not long ago at all now when companies decided to make money from ML, and people were saying, data is an asset should be leveraged to make a return. You're holding an expensive asset that represents some opportunity cost because capital you spent on it should be earning. And as a result, where that point of view was taken, data was at least expected to function as a profit center. It really varies.
Interesting, just like from my own personal experience. So I don't know if many of you know, but I'm a data engineer at John Lewis, and it's just interesting to see how when you were saying about data products, that's literally how we look. So we obviously, as a larger organization, will have various streams of data coming in, and we see each stream of data coming in as a data product. And before we start working on this, specifically with my team, we make sure to know exactly what the value will be. Like, for example, so one of the products I've worked on would have saved the company £6 million a year. So it's actually quite interesting to know how your work as a data engineer impacts the water company. Just my 2 cents. But anyone else have any points of view? Yeah.
Me again. Sorry. So I've spent my whole career working in big organisations, right? Working in one and then working with customers who are big organisations as well. So I just want to sort of pick up on some of your points you said earlier. Your big stack of paper, right? Of all of the things, right? So if you're an engineer or an architect or you do any of this stuff, right? A lot of that stuff is actually about being able to talk to other people. Right, so it's about having a common language. So the reason that large organisations get themselves tied up in all these processes and requirements and component models and all that good stuff, right? And then, you said it's a bit of a fact of life. Sadly, it is, but it's also about being able to understand. And data is one of those things. It's a bit of a mystery topic, right? Especially things like AI. And I think from a career development perspective, if you're early in your career, or even mid-level or up to the top, right, you may find yourself working in an area that is a mystery to other parts of the business. So learn how to understand, learn how to talk other people's language. So the combination of things you said at the end, I thought that was really really insightful there. So it's all about communication, really. And another one, just another comment. I've seen so many companies that have no idea what they've got. They have no idea what data they've got no idea what it does, they've got no idea who owns it, and then someone's going to come along, like a CTO like me, and say, let's go and do a big data project or a big AI project, and all that's going to live and die by the data, and it's this sort of universal dirty little secret of IT, right? So often before you can do IT architecture, you have to do IT archaeology. And nobody knows about that. So that's one thing I've seen from working with hundreds of customers over 27 years or something in the field. So if you see those things in your organisations, don't be scared, don't be embarrassed, right? Learn how to talk to other people in your organisation, learn their language, expect them to not be able to understand what you're saying and your communication. One of the things about on the cell, right? So the cell thing is communication is what happens at the other end. So often ineffective people can talk and they'll communicate, they'll say something and not necessarily understand if it's been. So it's like, a network engineer, right? So I'm sending all my packets, but I'm getting no acknowledgements coming back. So that's all about just the human part of it, as you said earlier, right? So just recognise that, as people. So I thought that was fantastic.
Thanks. Yeah. I mean, I suppose I'll show that picture of a big stack of paper. But I think it's a big trap to fall into to say, oh my God, this overhead. People are so stupid. Oh my God, capitalism, and so on. In practice, those things do exist for a reason. Maybe they aren't doing the job the way they should, but they exist for a reason. And you've got to leverage them and get the value out of them, even if it's hard.
Thank you. That's an interesting term, data archaeology, because it kind of really feels like that sometimes, especially when you're migrating systems. Anyone else? Oh.
Hi, firstly, thank you for the presentation. It was hilarious, but also very informative. I wanted to ask a question around domain knowledge. So I'm a data engineer, work for a consultancy, and the project that I'm on is a large multinational. So pretty much everything you said, it really resonated, but with the added complexity of being a consultant. So I'm part of them, but not really, and who I interact with in the business is like a specific team within that entire business. I just wanted to ask, what are great ways to kind of gain that domain knowledge of that client? Because as I was listening to your presentation, I was just like, yeah, I can really see that my domain knowledge is okay, but there's so much more I could know that would honestly help kind of steer them towards different paths sometimes. So we should definitely do that, things like that. Thank you.
Yeah, thanks. Good question. Because it's a good question, I don't necessarily have a canned answer to that. I can suggest some things which I think I have seen work for other people rather than having a particular point of view on it. One thing is that remember I gave an example earlier about when I deliver a list of oil exchanges or will I deliver a data product expressing our position relative to oil exchanges and sell it to people? Doing the latter one would teach you a lot more about the bank's oil exchange business. You would have to work out what each field meant. You would have to understand which people need to have it if you're trying to sell it to them and so on. So treating data as a product can help with developing domain knowledge, because it means if you're doing data, you're also doing a bit of business, even if it's only internal business. That's one thing. Another thing I'd say is you've got to look as far upstream and downstream as you can. So, often data engineers are doing mappings, and you're saying sort of in table 5 of database 6, column 8 seems to mean the same as column 45 in database A. We've kind of all been there. It's like sort of paying your dues kind of thing, I guess. If you treat that as mechanical, then you will learn less than if you just challenge it. Just call up the guy that owns database B or whatever, and just sort of say, how does it come to be like this? Great work on database B, and make friends with them. And ultimately, the background information you thus acquire of the organisation will help you understand what's actually going on. And I have to say, the other thing is, it's probably a human nature thing, but ownership of a report, of a business-facing report, tells you a lot more than ownership of the transaction back end sometimes. Problems and dialogue tend to accumulate at the sort of outward end of the data pipeline, the reporting end, not the sort of acquisition end. So having a knowledge of the reporting end, even if you work far up the data stream, is very valuable. Those are kind of suggestions that popped into my mind. They're in no way definitive or even a useful response, but good question, basically.
I think it all comes from business as well being involved in that process. Again, bringing back to John Lewis, when I first started, we actually had the business taking the initiative to put together all the kind of streams. For example, in John Lewis, we're undergoing a massive migration project where we're migrating on-prem databases into the cloud. So I got to know what the on-prem databases were, what they were holding. So it's kind of again, having that conversation, not being scared of making friends, because they're people too. I think one more, and then we'll finish. Okay, if no one else has anything else, then thank you, Ben, and thank you, Nick. And thank you, Zago, for hosting us, and Kindle for sponsoring us, and WeShape for partnering with us. So many people to thank. Thank you all for coming. We have another 40 minutes. So we can go back to the kitchen for another 40 minutes to have a little chat, and then whoever wants to can join us at the at Back to Mines, the pub, not mine, later. Okay, thank you. Thank you.